Okay, in this video, in a previous video, I talked about like terms and how to identify terms that are alike or called what we call like terms. In this video, I'm going to go through several examples on how to combine like terms, which helps you simplify mathematical expressions. Okay, so let's look at the first example here. So in the top left, number 1, we have 2x squared plus 6x squared plus 5x plus 9. All right, so we've got 4 different terms, okay, that we're adding together. All right, so we've got to figure out, okay, if I want to simplify this expression, I've got to figure out, okay, what terms are like terms, and if I have any, then I can combine them. And let's take a look. So I have 2x squared and 6x squared. These two are like terms because they have, the variable x, and that variable x has they have the same exponent of 2 as well. Okay, so that's important. Now you might think, okay, wait a minute, they have a different coefficient. Like we have the first term has a coefficient of 2, and the second one has a coefficient of 6. So how can they be alike? Well, as long as they share the same variable and that variable has the same exponent, then they are considered like terms. So even if the coefficients are different, in this case, they're still like terms. So if I were to add those, that's like me taking 2x squareds plus 6x squareds. Well, 2 plus 6 is 8, so that leaves me with 8x squareds, or in other words, 8x squared. Okay, so we just combined these two together, all right? And then we got to ask ourselves, can I add this other term with them, the 5x? Because it has an x, just like 8x squared has an x. But it doesn't have the same exponent of 2. So in that case, 5x is not a like term with those other two, okay? And so because of that, we have to leave it alone. So we're going to have 8x squared plus 5x still there. And the plus 9, we can't combine the 9 with anything because the 9 is what we call a constant, which is just a number by itself. And if there's no other numbers that are just by themselves, and in that case, that means there's no other like terms in this expression to combine. So this is as simple as we can get this expression for number 1. All right, let's go to number 2. Number 2, we've got 3a squared minus 5a squared plus 2a minus 6x. Okay, so we've got 4 different terms again. Let's look at what might be like terms. Well, 3a squared and minus 5a squared. So 5a squared and 3a squared both have a squared in their term. So that means they have the same variable, and that variable has the same exponent involved. So those are like terms. So we got to do 3 minus 5, which is negative 2, and keep the a squared. So now it turns into 3a squared minus 5a squared is negative 2a squared. All right, and then we're going to still write in there, we're going to write in plus 2a and minus 6x. That's as simple as we can get that expression, okay? Because 6x, there's no other term that has x with it, and 2a cannot be combined with negative 2a squared because even though they have the same variable of a, those a's don't have the same exponents, okay? All right, number 3. We'll go with green now. So number 3, 3xy plus 4x minus 7xy minus 9y. All right, so this is a little different because these two terms, 7xy and 3xy, they both have 2 variables in their term, x and y. And they both have, because they both have the same variables, we can go ahead and combine those. Now, this is where some people get confused. They think, oh, well, so I should be doing 3xy plus the 7xy. Oops. Okay, but that's not the case. You're not adding those. You're going to always look at you want to look at the operation symbol that is before the second term that you're combining. So in this case, the second term we're combining is the 7xy, okay? As you go left to right, 3xy is first and then 7xy. So in that case, you want to look at the operation symbol right before the second term, 7xy, which is a subtraction sign. So that means when we combine these, we need to do 3xy minus 7xy, okay? So if I do that, okay, well, 3 minus 7 is negative 4. So I'm going to end up with a negative 4xy when I combine those two terms. And then I still have plus 4x and minus 9y. So now I've got to ask myself, are there any more like terms? Well, 4x has x in it, but it doesn't have a y with it, so I cannot combine these two terms. And then 9y has a y in it, not like negative 4xy, but negative 9y doesn't have an x. All right, so I can't combine any more. There's no more like terms here. So this is my final simplified expression. All right, number 4. We've got 10n minus 3n to the third plus 9n to the third. All right, so we've got two terms right here that are like terms, 3n to the third and 9n to the third. They're being added. So let's see. So, but technically, this one's a little different. So we need to be careful here because we need to keep this subtraction sign. Well, no, we don't. No, we don't. Okay, we're good there. All right, so let's do 3n to the third power plus 9n to the third power. Okay, so those are both like terms. Let's add those together. If I do that, we will get 3 plus 9 is 12. So we'll have 10n. We keep the minus sign, but now it's minus 3 plus 9 is 12n to the third power. Okay, so we've got 10n minus 12n to the third power. Okay, well, both of these terms now left over have n, but they have different exponents, right? And so because of that, they're not like terms, and therefore we can't do anything further here to combine like terms. All right, let's go to the last two examples. Number 5. We've got 8r plus 10 plus minus 5. Okay. All right, now this one's a little different because we have two constants. So in other words, we have two numbers by themselves, 10 and 5. And those are, if you have two constants or two or more constants, those are considered like terms with each other because they're just numbers by themselves. They don't have a variable, so they're alike in that way. So we're going to keep the 8r because there's nothing to combine 8r with, but 10 minus 5 is a positive 5. So now we have 8r plus a positive 5. And that's all we can do with that one because now we have a number by itself, 5, and a term with a variable in it. And because it has a variable, we can't combine it with the 5. All right. So last one is number 6. Number 6, 9x plus 5 plus 3 plus 4x. So I see two constants that we can combine with each other, 5 and 3. And in between them is an addition sign, so we're going to add those, so that'd be 8. All right. And then 9x and 4x we can combine as well. Now, the question is, what do we add, subtract? Well, if you look at the symbol right before the second term involved, right before the 4x, there's an addition sign, which tells us, okay, 9x plus 4x. All right. And in that case, 9 plus 4 is 13. So 13x and plus a positive 8 is what we are left over with after we combine like terms.